about explaining the genetic breakdown of ball pythons. Whenever we were getting into it, it was really hard for us to figure out everything that was going on, and there wasn't a whole lot of instructional videos to break down how it all works, so figured now that we understand, we should make a video so people could reference it. First thing is incomplete dominant, or also known as codominant. A few examples are vanilla, Enchi, Mystic, Pastel, Fire, Lesser, Mojave, Yellow Belly. Those are just a few. There's a whole lot of incomplete dominant genes with ball pythons. So I'm going to explain how this works. If we have a pastel and we breed it to a normal, 50% of the babies are going to be pastel, 50% are going to be normal. Alright, if we breed a pastel to a pastel, 25% are going to be super pastel, 50% are going to be pastel, 25% are going to be normal. So what makes a incomplete dominant incomplete dominant? Anything that makes a super form makes is an incomplete dominant animal, right? If there's if it doesn't make a super form, then it's considered a dominant trait. Alright, so if you have a super form and you breed it to a normal, 100% of the babies are going to be whatever gene the super form is. So in this instance, if you breed a super pastel to a normal, 100% of the babies are going to be pastel. Alright. Next we're going to go to dominant traits. Dominant means that there's no super form. A few of them: spider, pinstripe, calico, champagne. If I breed a spider to a spider, I'm going to get 50% spider, I'm going to get 50% normal. There's no super form of a spider. Okay. Alright. Acts like super is a term that Kevin McCurley basically made up, which is a really good term. It explains what's going on. Acts like super is two genes that combine together to make a super form. Okay, if I breed a Mojave to a Mystic, I'm going to make a Mystic Potion. Okay, they're two different genes, but they make a double gene. As like a super pastel would be basically two genes of pastel. This is two genes of Mystic and Mojave. Okay. Also, Fire and Vanilla make the vanilla cream. That also acts like super. Another two genes that go together is the Yellow Belly and Spectre that make the super stripe. That's also acts like super. So if I breed a Mystic to a Mojave, 25% of the babies are going to be Mystic Potion, 25 Mystic, 25 Mojave, 25 normal. Alright, if I breed a Mystic Potion to a normal, only thing I will get is 50% Mystics, 50% Mojaves. You cannot recreate an acts like super when bred to a normal. So if I breed a Fire and Vanilla together, I'll get a vanilla cream. If I breed that to a normal, I'll only get Fires and Vanillas. Okay, so it acts like a super, saying that it will not create normals, but you can't recreate it by just breeding it to a normal. Same thing with incomplete dominant genes. If you have a super pastel and you breed it to a normal, you can't create another super pastel. Only one gene will transfer. Alright, here's the hard one. This is what really took a lot to understand, but we basically got it down now. So these are recessive genes. Recessive genes are something that takes both sides of the allele from the parents to make a visual gene. With a pastel or a lesser, if the dad's a lesser and the mom is a normal, then it can still create a lesser. With a recessive gene, it takes both parents to carry the clown or axanthic or pied gene for it to be a visual recessive. Alright. So, here we got. If we do a visual clown, if we breed a visual clown to a normal, all of the babies are going to be 100% het clown. Not visual clowns, but they're going to look normal, but be 100% het for clown, meaning half of the allele structure will have the clown gene and half of it will have the normal gene. If you breed a clown to a clown, all the babies will be visual clowns. 100% of the babies will be visual clowns. Alright, so if we breed a clown to 100% het clown, half the babies will be visual and half the babies will be het. Okay, het, again, meaning that it's carrying the gene but it's not visual. It looks like a normal baby. Alright, so a lot of times you'll see people selling pos het. Pos is possible het. So basically it's saying that it's possibly heterozygous for whatever recessive gene you're looking for. So if we're breeding a 100% het animal, meaning half of the structure is het for whatever recessive gene, and you're breeding that to a normal, only 50% of the babies will be 100% het clown, but they will look like normals. The other 50% will be normal. Okay, so basically they're saying possible het. I'm selling you this baby. It might not even have the clown gene or the albino gene or any of those genes. So you're taking a gamble, basically saying, if I have 2 eggs here, one of them is technically going to be het for the recessive gene of clown, and the other egg is not going to be any recessive gene carrier at all. So you're basically taking a 50% chance of getting the heterozygous animal. The reason people buy heterozygous 100% het or 50% het animals is it's a really cheap way to get into the recessive gene. A visual clown female might be $2,000. A het female might be $200. So you're taking the chance of, or you're getting 100% het, you're paying a little less money, it's going to take more work to get to the visual form. Alright, this is where it gets a little confusing. If you breed 100% het to 100% het and you get 4 eggs, we're just using 4 to be an easy number, 100% het to 100% het, you'll get 1 visual clown. You'll get 2 non-visual clowns that are 100% het, but will look like a normal. And you'll get 1 normal that is not het for the recessive gene at all. So if you breed 100% het to 100% het and it's not visual, they call it 66% het for whatever gene you're looking for. Okay, all of any het animal is going to look like a normal but be carrying the gene. Now, basically the reason it's 66% is because the visual clown on 4 eggs, you can count the visual clown out because it's obviously a clown. Okay, so now out of 3 eggs, 2 of them are going to be 100% het clowns. 1 of them is going to be a complete normal. So you're basically taking a gamble, which is better than 50-50 chance. Now you're doing a 66% chance of the animal that you're buying is actually het for what you're looking for. Now again, like I said, the reason people buy hets is it's a really cheap way to get into a recessive gene. It does take a little longer because you have to raise up the animals and rebreed them just to get the visuals, but it's definitely a much easier way to get in. Every single het being 50%, 66%, if it's heterozygous for the gene that you're looking for, which usually you'll have to breed it to a visual or another het to prove it out, to say that it is actually heterozygous. If you any animal that's 100% heterozygous has the gene on half of it. Okay, if it's 50 or 66%, you're basically taking a gamble saying, does it have it or not? You'll have to raise it up, breed it to a visual, or breed it to another het, and hope to get animals. Alright, so that explains that. If you do decide to buy hets, like I said, it's a cheap way to get in. Make sure you're dealing with people that you know. Make sure you're dealing with people that are working with the actual gene that they're selling you. Do some research with that person. Make sure that they have albinos, or make sure they have genetic stripes before you start buying hets from them. You always want paperwork with a het. Make sure you get pictures of the adults, pictures of the clutch, pictures of the babies, especially if they did produce, say, a visual in there. You'll say, okay, here's him with the visuals, this is your baby, same clutch mates. That's either guaranteeing that it's 100% het or that it's a 66-50% het. There is people that will try to take advantage of you and say it's het hypo, het albino, just to, not add a couple dollars to the ticket price. But just make sure you do research. Always ask for paperwork. Don't buy a het without paperwork. Alright guys, I hope y'all understood that. If y'all need to, shoot us a message or a comment and we'll get with you and help you understand. It is really confusing. I did want to say that we did just make a Facebook page for the reptiles. It's pretty new and we don't have a lot of people on there, so if you guys get time or want to, like us on our Facebook page and give us some feedback. If anything, just something to talk about. Here's the info for our Facebook page. And we appreciate you guys watching the video. We hope that, I know it's kind of intermediate or beginner, but we wanted to give people what we didn't have whenever we were starting and try to figure it out. So thanks so much for watching, and we got another video coming after this one. Thanks.